Now that we've covered HTTP methods, let's go ahead and examine the request and the response objects that we've been talking about. Here, if we look at our request response between a client and a server and the methods we went over, we know that every single request, whether it be a get, put, post, or delete, every request from a client is going to have some form of a response back from the server. And that's what we're going to focus on in this screencast. We're going to focus on the request and the responses and what makes them, or what attributes they have, so that we can better understand them. Here you can see I've loaded Neumont.edu, and this is simply an HTML web page. It's put together by a web app in the background, but when it gets to us, it's really just HTML. If we remember from learning HTML and CSS, and we're inside of Google Chrome, you can follow along and actually see the requests on your machine. We do that, of course, by using the inspect for the page, which opens up the Chrome developer tools. And normally it defaults to the page inspection tab right here, where we can actually see the HTML elements. We can highlight them in the page. We can use this little tool to look at the HTML elements, and that's extremely useful when we are looking at the HTML that we got back from a request, particularly a GET request. Now, if we want to actually see how the resources and everything are coming over to our computer from across the internet, we can use the Network tab. So go ahead and switch over to the Network tab. Since I've got the text really large so we can see it in the screencast, I'm going to take up my entire browser page, or almost my entire browser page, in order to allow us to see what's going on in our network activity. Now, since this page was loaded before I opened up my developer tools, I'm going to go ahead and refresh the page, which is going to go ahead and do all of the requests that build this page. And we're going to be able to see here that to build this one page, it took, if you look down here in the left-hand corner, it took 26 requests for resources to build this one HTML page that we have loaded in our browser right now. And if we think back to our initial discussion about HTTP and how we use it to request all of these web resources that we build into our pages, and the fact that those resources can come from pretty much anywhere across the internet, I think it was this one right here, that we could get ads from an ad server, we could get videos from a video server, we could have an assets server that just serves up all of our images and stuff like that. And then we can have our web server that actually serves up the dynamically built content like the HTML pages. Well, with that, we can see that, man, we can get a lot of resources just to build one page. So I'm going to go right here to the actual call for the Neumont.edu web page. We can see that it's HTML just by the less than greater than. And then you can see that these are all JavaScript resources. In other words, we're loading a ton of JavaScript files. And here we're loading a bunch of images. In fact, the majority of those requests are images, JavaScript, and then we've got a CSS file being pulled in right here, more JavaScript, and then some web fonts. So some fonts are getting pulled in, more images, more images, more images, more images, more JavaScript. All right, well, we're going to look right here at this HTML one. And so when we click on one of these resources, the inspector actually allows us to see both the GET response or the GET request, so what makes up our request, and then we can also view what makes up a response. So here, let's go ahead and look at this. On headers, we can actually look at what the request looks like, where the request was going, as well as everything that makes up a request. So I'm going to go ahead and minimize some of these other ones. And we're going to look at this general request right here, the information that tells us about the request. And we're going to point some things out here. And as we talk about it, I'm just going to kind of label some stuff. Here we can see, and it's pretty clear just by its label, that this is the request URL. In other words, across the internet, we are trying to get to this particular domain, www.neumont.edu, and we want to pull the resource that is at this path. Now, since we're going to the root of this website, we're actually pulling whatever is at the root of the website with just this single slash. which if we think about our regular structure of a website, which we've talked about in other videos, the common place for a web server to look for the root document, it's going to be looking for like /index.html, and it kind of fills in the rest of the path for us. And so when we call just the domain itself with just a slash on it or no slash, the web server will actually add the rest of the path to it. And then we get back the index.html page for that website. So really what we're asking for is the index.html, or the home file, the root file for the website. And then of course we've got right here the HTTP method, which in this place we're just calling for a resource because we would like to read it. So we're using the get. HTTP also provides status codes, and there are a lot of different status codes that you're going to need to become familiar with. So make sure you go to the Mozilla Developer Network and look up HTTP status codes and make sure you know what the most common ones are. One of the common ones is a not modified status of a 304, meaning that I've already been to this HTML page and I've actually already pulled the HTML and it has been cached by my browser. And so when I refreshed the page and I asked for it again, it actually sent a request and asked the server if it has changed or not. And then the server responded and said, nope, you've got the latest copy, no need to send it again, so just use your cached version. And so we're actually pulling a cached version of this HTML from the browser's local storage. Now, if I cleared my cache and I went to Neumont.edu again, we would get a status code of 200 here, which means okay, and it would have loaded this HTML file brand new for us and cached it for the first time. The remote address right here refers to the IP address. Remember when we talked about networking, we have the human readable domain right here, and it of course corresponds to a machine readable or more machine friendly IP address. So we would have this right here and then correspond to the remote address of the server from which we're getting the information. So this is the request itself. It's actually pretty simple as to what it allows us to get from, or make a request to a server, sorry. Now let's go ahead and let's talk about the request headers. Now headers are different attributes that we can set on a request in order to tell the server different things that we're willing to accept, as well as different things that we want, and help modify the response that comes back from the server by notifying the server about what we're looking for with a little bit more metadata or a little bit more information that we're interested in. So let's go ahead and look at this really quick, and we'll identify some of the important things here. The accept header, which is right here, tells the server what we are willing to accept back from it as a response value. In other words, the data that we're going to get back in the response from the server, we're willing to accept plain text or HTML, application or XHTML and XML. Application is just XML, images as a PNG, all kinds of different things. And we can set these to what we want. In fact, we can set the accept header to just JSON if we were calling a web API. And you'll learn more about that when we start building APIs with Express. We can talk about the encoding right here. We can tell the server that we're willing to take some compressed files. In other words, we're saying, server, we understand the gzip protocol. So if you want to gzip everything that you send over to us so that it's a smaller package and gets here faster, our browser actually knows the gzip protocol. So it will unzip any compressed files that you send us. So we can do that. We can also specify the language. So right here, we're specifying that it is a US version of English. And depending upon the machine you're on and the browser and what country you're in, this accept language can be anything. It could be German, Chinese, Russian, Spanish, anything like that. We can talk about cache control. In other words, how long we're going to cache things, what the max age is, whether or not to keep the connection alive. And then, of course, the cookies that we're willing to accept, or cookies that we have that we need to send back over to the server in order for the server to identify who we are. Cookies or often used to help control sessions. And remember when we talked about the fact that HTTP is a stateless protocol, meaning that it doesn't remember who is talking to who or what the last conversation was about. Well, cookies allow us to store session IDs, and then these session IDs, like this one right here, which all of this makes up the session ID. This, if we send it back to the server can go look up this ID and find out who the user is or who's making the request and what happened on the last request if the server is storing detailed information about the last session that the server had with whatever client this is. So those are some of the headers that we can control when we make a request if we are making or building requests manually. Of course, right here, we're just calling a regular web page and we're letting the browser do it all for us. So the browser is actually automatically setting all of these request headers for us in order to communicate with the server. Now, when we start using JavaScript and React, we will be actually manually creating all of our HTTP requests that go to the server, and we will be able to modify any of these headers as needed. Those are the request headers. Now, in the response, if we look at the response headers here, it has similar headers, but these headers are the server actually sending information to us to let us know a little bit more information about it and what it allows and accepts and what we can do. And let's mark off some of these that are really important. Here, this one right here, which is the access control allow methods. This is the server telling our client, which is the browser right now, what HTTP methods it allows. And in this case, it allows a get and a post and options. And we haven't talked about options. The real ones that we're concerned about when we're building an API are get, put, post, and delete. You can see that this server actually does not accept put and it does not accept delete. It only accepts the get and the post, meaning that it will allow us to get resources or pull resources from the server, and it will allow us to post information to the server, like if we use a web form to say, hey, I'm interested in attending Neumont, send me some information. It'll allow us to post stuff, but it will not allow us to update using a put, and it will not allow us to delete stuff from the server with a delete. So the server is actually telling the browser, hey, these are the only things I'm going to allow you to do. And then access control origin, you can read about that one, the date that everything happened, and then the last modified date on the document. And here's some cool information right here. This is the server, and it's telling us what server application or web server is actually running this entire website. And in this case, it's Microsoft's IIS web server that is running this particular application on the server where it lives. And then this tells us what actual language our application was built in. So this website, this Neumont.edu website, is actually powered by ASP.NET and is most likely written in the programming language C#. But it's using the ASP.NET web application framework in order to do all the stuff that it does on the server. Now, in this class, we're going to be using Express. Express is the Node and JavaScript counterpart to ASP.NET. So that's a nifty little tidbit right there for you. All right, so request and response, and using this response tab right here, we can actually look at what came back from the web server. And as expected, it was the HTML document because that's what we were asking for. So this is the actual HTML that was returned to us, and it is what gets rendered here inside of our browser. Cool thing too to notice is that all of these script tags, as well as all of these script tags, as well as all of the images that are inside of this particular website, like this logo and all that kind of stuff, all of these, after this web page, you can see it's the first one in our request stack. Once it gets pulled and the browser starts to read it, it actually identifies all of those script tags and it actually starts making requests to pull those in. And as it runs into images, as it's building this HTML page, it's going to ask for those images. And it's not until all of these requests that were actually inside or embedded inside of our HTML document that all of those things return and get loaded into the page as images as well as JavaScript resources that the page actually completes. So we had 76 additional resources that were identified inside of this HTML page that also had to be loaded in order to make this an effective and fully functional HTML page with the appropriate icons, fonts, and JavaScript to run the interactivity that's found within this website. Really cool tool, the Chrome Developer Tools. Of course, all you have to do is right-click and do inspect. You get yourself the elements and then the network. Really important tools as you begin to build web applications. And that was our overview of a HTTP request as well as its basic attributes and its headers, as well as the response headers and the response content that comes back. Using that tool will come in extremely handy when you begin to build your own single page React application and as you try to check to see if its requests going from the browser to your API server are actually functioning.